Morning, I'm Corley Holbrook. I'm with USDA ARS, but I am located here at the University of Georgia campus in Tifton. I'm going to just talk to you briefly about a couple of varieties this morning. The first one, you're all familiar with Tifton. We released that in 2008. It's a nematode-resistant variety. If you have a nematode problem, you understand how severe this can be. Here's a slide showing galling on the roots and the pegs and the pods. The problem with this pathogen is it produces about 300 to 500 eggs in these egg masses, and it has a life cycle of about 35 days. So for a long season crop like peanut, where you have 140, 145 days, the populations of this pathogen can explode over the season. Nematologists estimate that about 25% of the acreage in the southeast has damaging populations of peanut root knot nematode. So like I said, we released Tifton. It actually has a gene that comes from wild species. That introgression work was done out at Texas A&M. It took over 30 years for that individual to introgress that into agronomically adapted germplasm. They released a couple of varieties out there, but they were very susceptible to tomato spotted wilt virus, so we couldn't grow them here in the southeast. So what we did was we crossed one of their varieties with C99R and combined the resistance to tomato spotted wilt with resistance to nematode. The resistance to nematodes that we get from that introgression is near immunity. It also has good TSWV resistance, it's medium maturity, and we were fortunate to also get some moderate resistance to late leaf spot. Picture's worth 1,000 words. These are some pictures from Dr. Tam Brenneman's field plots. He calls this the Green Island effect. Here's Tifton without any nematicide in a heavily infested field in comparison to susceptible genotypes. Some of these susceptible plots even had some nematicide applied. But your best bet, if you have a field like this, is a variety that has that genetic introgression. So, as soon as we started talking about Tifton, many facets of the industry started asking us if it was high oleic. Excuse me, and it's not high oleic, but we worked with Dr. Peggy Ozias-Akins using marker-assisted selection to combine nematode resistance with high oleic, and have recently released Tifton V high oleic. That came from a cross that we made with Tifton by Florida 07. Of course, we get the nematode resistance from Tifton. We get the high oleic trait from Florida 07. Like I said, we worked very closely with Peggy's group with marker-assisted selection for this. This is genetic assay for nematode resistance. Each of these dots here are triangles as an individual plant in our population. These plants are all homozygous susceptible. In other words, they're susceptible, they breed true for susceptibility. These are all homozygous resistant. In other words, they're resistant, they breed true for resistance. These individuals are heterozygote. They have one allele for resistance, one allele for susceptibility. This is very powerful information for a breeding program. So it's very exciting that we're at a point now in peanut breeding that we can get this type of information. Peggy's lab also gives us information on the high oleic characteristic. Each one of these lines is an individual plant in one of our populations. The green lines are homozygous for high oleic. They breed true for high oleic. The red lines are plants that are homozygous for normal oleic. They breed true for normal oleic. And the blue peaks are plants that are heterozygous. Once again, very powerful information for a conventional breeding program. So using that information, we selected Tifton V high oleic. It's got good yield. Once again, near immunity to the peanut root knot nematode, high oleic. good tomato spotted wilt resistance, moderate resistance to leaf spot, and it is medium maturity. I think I made this comment last year, and I'm going to make this comment again this year. If you are using a variety that has this introgression for nematode resistance, it is near immunity. But I would caution you that don't get away from good rotation, even though you have this. This tool perhaps could break, the pathogen could perhaps overcome this resistance. And if that happened, if you were still practicing good rotation, you would greatly extend the time that you could use this tool before you had a problem from a nematode that overcame the resistance. And of course, you also have other soil-borne pathogens that you're going to need good rotation for. So a couple of comments about marker-assisted selection. I know Steve Brown's going to talk to you in just a minute, but I'm very excited about this. You're all pretty aware of the Peanut Genomics Initiative that's been going on for almost 5 years now. The reason I got involved in that effort was because it seemed to me that we were going to develop tools that could be greatly beneficial to peanut breeding programs. And I think we've done that. And I think this slide really clearly illustrates that. In 2008, we released TifGuard strictly with conventional breeding. We used greenhouse screening techniques, field screening techniques. There were some primitive markers for the nematode resistance. Peggy and I talked about that, but it just didn't make sense to use them. They were expensive. They weren't user-friendly. But about that time, Peggy said, well, we can develop better markers for nematode resistance. And so we tested it in 2008, and it seemed to work very well. Her group also developed markers for the Howell Lake trait. And so for the next several years, we had about 1,000 samples going through her lab, and she was giving us that information back in an Excel sheet on, what's the genetics of your individuals out in the field. They continue to make advances every year. In 2012, they added a high throughput equipment, and they said we can do more than 1,000. And I said, well, how about 4,000? So they did 4,000. They said, well, that went pretty smooth. We could probably do more. So I said, well, how about 7,000? That went pretty smooth. So I said, well, can we do 10? So the last couple of years, we've done 10,000 samples, and actually, our group is the bottleneck now. They could do more, but we can't do any more going out there and sample in the field. We've recently changed our procedure, and we've alleviated that bottleneck, so I think we can now go up to 15,000. The deal was, all this was just nematode resistance in Howell Lake. We really need more markers, and that's what the Peanut Genomics Initiative is going to provide us. Last year we began using leaf spot in some of our populations in the field, and actually this winter we began using some additional markers for leaf spot, and we've begun an accelerated backcross breeding program to try to convert several cultivars and breeding lines to leaf spot resistant versions. And I think using this technology that we have now, in the next few years, we're going to have several products coming out of that effort. So we're really excited about that. And lastly, my last slide, and I used this slide last year too, I think, is marker-assisted selection does not equal GMO. If you don't do this every day, you're not real familiar with the terminology, but marker-assisted selection is still conventional breeding. It doesn't equal GMO. I have no problems with GMOs. But some people do have a real emotional problem with GMOs, and we shouldn't have to fight that battle because we don't have any GMO peanuts. Thank you very much.